Okay. Did you get any idea? First of all, we have to find the corresponding central angle, is it? We have to find the corresponding central angle for drawing the pie chart or circle graph. Here, as we know, what is the sales according to ordinary bread? The sales according to ordinary bread is 320 rupees. 320 rupees. Okay, first of all, we have to convert this 320 into fraction. How will you convert this 320 into a fraction? The total sales is 720 rupees. That's why the fraction form
320 divided by 720.
Yes, the fraction form should be 320 divided by 720. Okay, how will you simplify this 320 divided by 720? We can simplify it. How will you simplify? Easily we can write it as 32 by 72. Is it? 32 by 72. And after that, how will you simplify it again? Both 32 and 72 are multiples of 8. Is it? Okay, then how will you simplify it? It's equal to 4 by 9. It's equal to 4 by 9. This is the simplified form of 320 divided by 720. And after that, we have to find the corresponding central angle. How will you find the corresponding central angle? For finding the corresponding central angle, we have to multiply this 4 by 9 with the 360 degree. 360 degree. Then what should be the product of 4 by 9 and 360? We know how to multiply a fraction with a whole number. While multiplying a fraction with a whole number, we have to multiply the numerator with the whole number and then replace our denominator. Then 4 into 360 divided by 9. While simplifying it, we will get it as 160 degree. So the central angle corresponding to ordinary bread is 160 degree. Similarly, you can see in your textbook, page number 80, the central angles of other items are given in a table. That is, according to biscuit, the central angle is 60 degree, and about cakes and pastries, it is 80 degree, and about fruit bread, it is 40 degree, and about others, it is 20 degree. So we have given the central angle corresponding to each of the items. So, using these central angles, we are going to construct or draw a pie chart. Okay, then first of all, as we know, we have to draw a circle of any convenient radius. We have to draw a circle of any convenient radius. You can draw it in your rough book. You can draw a circle with any of convenient radius. All of you please turn on a video. And after that, we have to mark our center O and just draw a radius OA. This is the radius OA. This is the center O and this is the point A. Then we have the radius OA. After drawing this, you just place your protractor on O. Just place your protractor on O. After placing your protractor on O, you just mark 160 degree. About 160 degree. That may be of like this. The angle 160 degree. It should be 160 degree. That is about, this sector is about ordinary bread. That is, we know that the central angle corresponding to ordinary bread is 160 degree. That's why we have drawn the sector of ordinary bread. That is 160 degree. After that, we have to draw the central angle of biscuit, which is 60 degree. For that, we are just placing our protractor on O along this line, along our newly drawn line. And after that, we are just drawing 60 degree. We are just drawing a 60 degree. This is about 60 degree. This is the sector corresponding to the item biscuit. This is the sector corresponding to the item biscuit. I'm just marking here the central angle, which is 60 degree. Okay, Sridev, please turn on a video. Okay, and after that, we are again placing our protractor on O along the newly drawn line. After that, we have to mark 80 degree. We have to mark 80 degree. That may be off like this. Maybe off like this. And after that, we have to draw 40 degree and 20 degree each. We are just drawing a 40 degree line here, and the remaining should be 20 degree. This is the pie chart corresponding to our given data. In this, each sector represents each of the item. We are drawing this using the central angles corresponding to the each item. First of all, we have to find the central angle corresponding to each of the items, which is already given for you in your textbook, page number 8. Using the central angles, we have to draw our pie chart or circle graph. First of all, we have to draw a circle of any convenient radius. After that, we have to mark the center O, and we just drawing a radius OA. After drawing that radius OA, we are just placing our protractor on O along OA and marking the central angle of the item ordinary bread, which is 160 degree. And after that, we are just placing the protractor on A along the newly drawn line and choosing our next central angle, which is 60 degree according to the sketch. And in this manner, we are completing in our central angles, and hence you will get the resulting circle graph or pie chart. Okay, did you get the idea of drawing a circle graph? All of you? Did you get the idea of drawing a circle graph or pie chart? What about others? Sridev, what happened? Please turn on a video.
Is the video on or off?
Okay, I think it's the back camera. Okay, after that you can see in your textbook page number 82, there is an exercise 5.2 given for you. Exercise 5.2. What about your exercise 5.1? You have some questions regarding to our histogram, that is exercise 5.1. Did you complete it? All of you? Okay, then why did you send me? I didn't get anyone's response. After this class, all of you please send your answers. That is exercise 5.1. Okay, and here is an exercise 5.2 given for you. Here, all of the questions are related to drawing pie charts and analyzing pie charts. You can simply answer it. It's very simple. It's all about pie charts and circle graphs. In your first question, you can see that there is a pie chart given for you. And using that pie chart, you have to answer some questions. And the second question, you have to draw a pie chart. You know how to draw a pie chart? First of all, drawing a pie chart, you have to find the central angles corresponding to each of the sectors. And after finding the central angle, you just draw the circle graph or pie chart. And the third question is also about drawing a pie chart. And in the fourth question, you have given the pie chart. And in the fifth question, it's all about drawing a pie chart. Okay. Okay, that's all about the section circle, graph, and the pie chart. Then we are moving to our last section, that is chance and the probability. Did you heard about chance and the probability? Chance and the probability, I think in your previous classes, that is in 6th and 7th, there should be about something about chance and the probability. That is, while discussing chance and the probability, we are always giving an example of tossing a coin or throwing a dice. Is it? Then what is the probability of getting head while tossing a coin? What is the chance? What is the chance of getting a head or a tail while while tossing a coin? What is the chance? There may be a chance of getting either head or tail while tossing a coin. We can't predict the exact result, is it? Sometimes our prediction may be correct or sometimes it may be incorrect. There should be two possibilities while tossing a coin. What's that? First possibility is it may be a head or it may be a tail. These are the two possibilities. And we can say that these are the equally likely possibilities. What's it? Equally likely possibilities. Is it? And such experiments, that is, in such experiments, we can't predict the result. So such experiments can be called a random experiment. It is called random experiment. In random experiment, we can't predict the exact result. We can't predict the exact result. That's why we are calling it as a random experiment. And we know that you have some examples given for you or some situations given for you. That is, sometimes it happens that during rainy season, you carry a raincoat every day and it does not rain for many days. There may be chance of raining or not. However, by chance, one day you forgot to take the raincoat and it rains heavily on that day. And we can't predict in every day. It may be raining, but we can't predict about it. That's why there may be a chance of raining in every day during the rainy season. Okay, the next one. Sometimes it so happens that a student prepares 4 chapters out of 5 very well for a test. But a major question is asked from the chapter that he left unprepared. There may be a possibility of asking questions in every chapter, but she has skipped one chapter, and unfortunately what happened? The major question came from that chapter she has skipped. That is, we have a chance of asking or getting questions from every chapters. That's the situations where we are using about chances. And after that, you face a lot of situations such as this, where you take a chance and it does not go the way you want to it. There may be lot of situations regarding to chance that is discussed here. That is called chance. And what is the result? Result means what is the outcome? Outcome is also known as the result. That is, while tossing a coin, what should be the result? It may be either head or a tail. That is the possible results while tossing a coin. And while throwing a dice, what happens? What are the possible outcomes while throwing a dice? There may be 6 possibilities, is it? There is possibility of getting 1, 2, 3, 4, 5 or 6. Either 1 to 6. These are the possible outcomes while throwing a dice. And here, while tossing a coin, head or tail are 2 outcomes of that experiment. Outcome is the result is itself known as the outcome. And while tossing the coin, what are the outcomes? What are the outcomes? Head or tail. They are the outcomes. And what is equally likely outcomes? What is equally likely outcomes? Equally likely outcome means there is equal chance for getting each of the outcome. That is, you know that while tossing a coin, you know that there should be equal possibility or equal chance of getting head or tail. There should be equal chance. And similarly, while throwing a dice, you know that there should be equal chance of getting either 1 to 6, either numbers 1 to 6. That is, the possibilities of getting an outcomes are equal. That is, possibilities of getting an outcome are equal. That's why it's known as equally likely outcomes. What is it? Equally likely outcomes. And using this equally likely outcome or this chance, we can link this content into probability. We can link chance to probability. And I think you have heard about probability in your class 7. Is it? In class 7, there should be a chapter, data handling. That is the 5th chapter. So the 3rd chapter, data handling, in which we have just started an introduction about probability and chances. What's about probability? Have you heard about the word probability? You should have heard about it. Okay, probability should be a number, is it? Probability should be a number between 0 and 1. Probability should be a number between 0 and 1. Then how will you assign the probability of each of the outcomes? How will you assign this probability to each of the items? While drawing our circle graph, we have find fraction form corresponding to each of the items, is it? That is, looking at our last example, that is about that baker shop, in which we have find the fraction form about ordinary bread as 4/9 and about biscuit as 1/6 and cakes and pastries as 2/9, fruit bread as 1/9 and others as 1/80. How will you find it? How will you find it? Outcome is divided with the total, is it? That's the same way we are finding the probability. That is, in the case of tossing a coin. While tossing a coin, we have how many outcomes there is? How many possible outcomes are there? 2 possible outcomes. So the total possible outcomes are 2, and among which one is head and other is tail. Then what should be the probability of getting head? It is a 50-50 chance, is it? It's a 50-50 chance. That's it. The probability is 1/2. It is 1/2. That is, the possible outcomes are 2. The number of possible outcomes are written in the denominator, and the chance of getting head is 1. There is only 2 outcomes. That is, total there are 2 outcomes. Among that 2, there is only one possibility to getting head, and the other one possibility is about getting tail. That's why the probability of getting head while tossing a coin is equal to 1/2. Similarly, we can see that the probability of getting tail while tossing a coin is equal to again 1/2. Then what is sum of 1/2 and 1/2? What is sum of 1/2 and 1/2? 1/2 plus 1/2. Denominators are same, 2. Then we have to just add the numerator, then it becomes 2/2. 2/2 is 1 itself. That is the total probability is equal to 1. And each of the probabilities are less than 1. And total probability is equal to 1. And what about throwing a dice? What about throwing a dice? While throwing a dice, what is the probability of getting 1? Sorry, probability of getting 5. Probability of getting 5. How will you give me 50%? There are 6 possible outcomes, not 1. Probability of getting 5. As we know that, what should be our denominator? Denominator should be total possible outcomes. How many possible outcomes are there? While throwing a dice. 6 possible outcomes. 1, 2, 3, 4, 5 or 6. There are 6 possible outcomes. So, our denominator should be 6. And we know that these 6 outcomes are equally likely. These are equally likely outcomes. That is the chance of getting 1, the chance of getting 2, chance of getting 3 and so chance of getting 6 are equal. There are equal chance of getting either the outcomes 1 to 6. So these are equally likely possible. So we can say that the chance of getting, or the probability of getting 5 is equal to 1 by 6. That is, 5 is the only one outcome among the 6 possible outcomes. That means it is equal to 1 by 6. Number of outcomes giving 5 divided by total number of outcomes. Similarly, what is the probability of getting 4? What is the probability of getting 4?
1 by 6.
It's again 1 by 6. And similarly, the probability of getting any numbers between 1 to 6 while throwing a dice should be 1 by 6 each. Because there should be equally likely possible or they are equally likely outcomes of a random experiment. The random experiment is throwing a dice. So there are equal chance of getting either the numbers 1 to 6. That's why we can say that these are equally likely outcomes. Okay, this is the probability. Then outcome as event. Did you heard about the term event? Event. What do you mean by an event? Event. Here, we are representing event as an outcome. That is, we have some random experiment and there should be a result or outcomes for that random experiment. The outcomes itself is represented as events in probability. Event means outcome or outcome as event. That is our next session. Outcome as event or events. Each outcome of an experiment or a collection of outcomes make an event. That is, each outcome of an event or collection of outcomes of an experiment. Each outcome of an experiment or collection of outcomes of an experiment is known as an event. That is, either each outcome or the collection of outcomes of a random experiment is known as an event. And in the case of, you have a question here, in the case of throwing a dice, we have the possible outcomes, that is possible events 1, 2, 3, 4, 5 and 6. These are the possible outcomes while throwing a die. What about the probability of getting a even number as our result or an outcome? What is the probability of getting an even number as our outcome? By finding the probability, we have to divide number of possible outcomes divided by total number of outcomes. What is the possibility of getting an even number while throwing a dice? Or how many even numbers are here among 1 to 6? How many even numbers are here? 3, 2, 4 and 6. Here is 3 even numbers. And what about the odd numbers? Odd number is also 3. That is 1, 3 and 5. So among these 6 possible outcomes or equally likely outcomes, we have 3 possibilities to get the result as an even number. So what is the total outcome, there should be 6 total possible outcomes, and among the 6 outcomes, we have 3 possibility to get an even number or either an odd number. Then what should be the probability of getting an even number while throwing a dice? It should be 3 by 6. 3 by 6 can be written as 1 by 2. It can be written as 1 by 2 itself. So, by throwing a dice, the probability of getting an even number is equal to 1 by 2. Or similarly, the probability of getting an odd number is also 1 by 2, which is given in a textbook page number 86. That is number of outcomes that make the event divided by total number of outcomes of the experiment. Event means what's the event here? The outcome should be an even number. That is the event here. Okay. After that, you can see there is an example given for you. What is that example? A bag has 4 red balls and 2 yellow balls. A bag has 4 red balls. 4 red balls and 2 yellow balls. 2 yellow balls. A ball is drawn from the bag without looking into the bag. What is the probability of getting a red ball? The balls are identical in all respects other than color. They are similar in all other aspects except color. There are 2 colors of balls, that is 4 are of red color and the remaining 2 is yellow color. And we have to choose a ball randomly from our bag without looking it. We are just closing our eyes and after that we are just taking a ball from the bag. Then what is the probability of getting a red ball? What should be the probability of that ball should be red? That is, we are taking a ball from our bag without looking on it. And what should be the probability of getting it as a red ball? How will you get test for? Probability is always in between 0 and 1. That should be less than 1. Here, how many possible outcomes are there? While drawing a ball from that bag, that may be of red ball, that may be of yellow ball. There are 6 balls. Total, how many balls are there? 4 plus 2, 6 balls. So there should be 6 outcomes. This may not be equally likely because 4 outcomes may be of red ball and other 2 items may be of yellow ball. That's why we can't say it as equally likely. That's why here total 6 outcomes are there. Total number of outcomes is equal to 6. Total number of outcomes is equal to 6. And how many red balls are there? How many red balls are there? 4 red balls. That's why the probability of getting red ball is equal to, what should be it? We know that we have to divide or we have to write the denominator as total number of outcomes. As we know, the denominator is 6 or the total number of outcome is 6. The total number of outcome is 6. And what about the numerator? What about the numerator?
4.
It should be 4 because there are 4 red balls given for us. That is the chance of getting red ball, or the probability of getting red ball is equal to 4 by 6. How will you get this 4 by 6? The total number of possible outcomes are 6, and among that 6 outcomes we know that there should be 4 chances of getting a red ball, or there are 4 red balls given for us in that bag. That's why the probability of getting red ball is equal to 4 by 6. Then how can you simplify this 4 by 6? Both 4 and 6 are multiples of 2 itself. So we can write as 2 by 3. So the probability of getting red ball is equal to 2 by 3. Similarly, what is the probability of getting yellow ball?
2 by 6.
2 by
6.
equal to 2 by 6. That is, there are total 6 outcomes are there. So we have brought our denominator as 6 and about numerator. In our numerator, we have brought it as the number of yellow balls. The number of yellow balls is 2. That's why we can write it as 2 by 6 and 2 by 6 can be simplified as 1 by 3.
1 by 3.
So the probability of getting red ball is equal to 2 by 3 and the probability of getting yellow ball is equal to 1 by 3. And you have one more question. Is it more or less than getting an yellow ball? Which one is greater? 2 by 3 or 1 by 3? Which one is the greater? 2 by 3 is it? So the probability of getting red ball is greater than the probability of getting an yellow ball. Because there is 4 number of red balls or 4 red balls are there. That's why the chance of getting red ball is higher. Because there is only 2 yellow balls and 4 red balls. That's why we can simply say that the chance of getting a red ball is higher. Because there are 4 red balls present in our bag. So the probability of getting red ball is more than or greater than the probability of getting a yellow ball. That is the example 3. And after that there is a small section, chance and probability related to real life. Chance and probability related to real life. Here is an example given for you. That is, how will you relate chance and probability to daily life or real life? Can you give an example for relating probability or chance to a real life? Can you link probability of or chance to your real life probability? For example, what is the probability of getting higher score or total rank 1 in your periodic exam? In your class, there are 8 students, is it? And they are equally likely possibility. There is equal chance of getting highest score for all of you in your periodic exam. So there are 8 equally likely possibilities. Then what is the probability of getting or for faith, what is the probability of getting high score in periodic exam? That should be 1 by 8.
1 by 8.
1 by 8 for each of you, the probability of getting high score is equal to 1 by 8 because there is total 8 students are in your class. So there are equally likely possibilities or 8 equally likely outcomes. That's why the probability of getting for each one is equal to 1 by 8. The top score is equal for each one is 1 by 8. And similarly, here is another example given for you. That is to find characteristics of a large group by using small part of the group. To find the characteristics of large group by using a small part of the group. For example, during election, an exit poll is taken. As you know, during election, there should be an exit poll is taken. That is, this involves asking the people whom they have voted for. When they come out after voting at the centers, which are chosen of hand and distributed over the whole area. This gives an idea of chance of winning each candidate and predictions are made based on it. Is it? We are predicting the chance of winning for each candidate based on our exit poll. Is it? Exit poll is given. How will you calculate the exit poll? By asking the people about to whom you have voted. It may be correct or incorrect. We don't know the correct answer. While depending on the answer that they have given, we are preparing an exit poll chart. So there may be a chance of getting the correct result according to exit poll and there may be an equal chance of losing the candidate. So using that prediction or the result of that small group, we are predicting the characteristics of a large group. This is an example for using probability and chance to realize. And there is another example, that is meteorological department predicts weather by observing trends from data over many years in the past. As we know, there should be weather updates in every day. That may be of correct or incorrect. Nowadays, we have heard about what is heavily rain. After saying it may be heavily rain, there should not be a raining. There should be an equal chance of raining or not. That is, we are relating the probability and chance to our real life. These are some example of connecting probability and chance to our real life. That's enough in our this chapter, data handling.